Okay, this is the last page of the 7.3b packet, Think About a Plan. So let's see what we need to do on this. We just follow along and then answer the questions that they ask us. So it wants us to draw a trapezoid ABCD in the space to the right. Mark the base angles congruent. Okay, so I'm going to draw a trapezoid, two pairs of parallel sides. Draw the legs in, A, B, C, D, and we're going to mark the base angles congruent. And label the vertices so that AB is parallel to CD. Okay, so we got AB parallel to CD, and angle D is congruent to angle C. Okay. Which two sides of the trapezoid do we need to prove congruent? Now we want this to be isosceles. That means we want to prove that AD is congruent to BC. That's what we need to prove. What type of polygons can you construct inside the trapezoid to prove that AD is congruent to BC? Hypotenuse. We could do something with triangles. Now we could do maybe a triangle down this way and one there. We have congruent angles, maybe something with that. This distance be the same. There'd be a right angle, angle, side. These two would be congruent, gives those two sides congruent. Maybe, possibly with diagonals. This triangle and this triangle, you got congruent angles, but we don't really know until we know it's isosceles that those are going to be congruent. So we'll see. But some kind of triangles. Let's look at number 4. What makes a set of lines parallel? Describe the relationship between two segments that are perpendicular. So we got a pair of parallel lines, and they're talking about two segments that are perpendicular to a parallel set of two segments that are each perpendicular to a pair of parallel lines. I guess like this, and have endpoints on the lines. So here's the picture they're talking about. So what can we say about these two segments? If these lines are parallel, then they're always going to be the same distance apart. So if you measure along the same angle between the two parallel lines, these distances are going to be the same. So those two perpendicular to the set of parallel line segments would be congruent to each other. So the relationship, the segments would be congruent. And they're also parallel. Perpendicular to a parallel line gives you the vertical line. Say if your line was horizontal, your parallel line was horizontal. Perpendicular to another line that's also horizontal would be another perpendicular line. So these two lines would be parallel to each other. Segments would be parallel and congruent. Okay, let's see what's up with number 5. In your segment, draw AE perpendicular to DC. So AE perpendicular to DC. So that's point E, and it's going to be perpendicular. And draw BF perpendicular to DC. So we drew those two in there. What must be true about the length of the segments? AE is congruent. Segment AE is congruent to segment BF. Put 3 marks on them. Those are made congruent. What must be true of angle AED and BFC? AED, they're both right angles. And mark it appropriately. Already got it marked. That one and that one are marked as perpendicular. How can you prove that AED is congruent to BFC? Explain. So here we have AED, BFC. We've got these two sides are congruent. They're both right triangles. These two angles are congruent. And the two right angles are congruent. So we have angle, starting at the D, angle to the right angle, which is angle, and then to the side. It's C, angle, the right angle, and side. So these two triangles are congruent by angle, angle, side. We could say triangle AED is congruent to triangle BFC by angle, angle, side. So again, you got this angle, you got the right angle, angle, and you got the side. And it goes with the other one, which is angle, the right angle, and then the side. Those were marked as 3's. So angle, angle, side pattern. And then how does this let you prove that AD is congruent to BC? Well, once these two triangles are congruent by angle, angle, side, AD and BC are congruent because those are corresponding parts of congruent triangles. So we could say that AD and BC are congruent by CPCTC. And we're done.